This lesson is an introduction to the binomial expansion. The first thing we're going to look at is the definition of the binomial expansion. Next, an explanation of the binomial expansion theorem. Then we will be using Pascal's triangle to help find the binomial coefficients. And finally, finding the binomial expansion of a number of terms. The binomial expansion describes the algebraic expansion of powers of a binomial. According to the theorem, it is possible to expand the polynomial x plus y to the n into a sum involving terms of the form ax to the power of b multiplied by y to the power of c, where the exponents b and c are non-negative integers, with b plus c equals n, and the coefficient a of each term is a specific positive integer depending on n and b. The binomial expansion theorem allows us to expand brackets to any power in a more efficient way. Let's take a look at the first 5. If we were to write out the expansions of these, we would get the following. Remember, anything to the power of 0 is 1. Now let's simplify, and we get this. Now let's just concentrate on the expansion results. And now, just look at the coefficients of the expansion. Do you notice anything? Well, you should notice that the coefficients follow Pascal's triangle, and the power of a decreases each time as the power of b increases. This is a very useful pattern to find. For example, if we were to expand something to the power of 3, we know exactly what the coefficients of each term of the expression. We know exactly what the coefficients are of each term of the expansion. This is true for all powers of expansion. Let's take a look at an example and it'll become more clear how to use this. In this example, we're going to expand 2 plus 4x to the power of 4. The power here is 4. This is also called the index. Using Pascal's triangle, we can identify that the coefficients we will be using are going to be 1, 4, 6, 4, and 1. So let's take the coefficients we're going to use, and then we can discard the rest of the numbers in the triangle. Next, we take our value for a, which is 2, the first value in our brackets, and write that in descending powers. Then we take our value for b, which is 4x, the second value in our brackets, and write that in ascending powers. Finally, we need to simplify each part by multiplying. So in the first row, 1 multiplied by 2 to the power of 4, and remember, 4x to the power of 0 is just 1. So really, it's 1 multiplied by 16 multiplied by 1, which of course is 16. Next, multiply out the second row. 4 multiplied by 8 multiplied by 4. This gives us 128x. And continue multiplying out the rows until the end. So our full answer will be 16 plus 128x plus 384x squared plus 512x cubed plus 256x to the power of 4. In this example, we are asked to find the expansion of 2 minus 3x all cubed. Once again, we take the coefficients from Pascal's triangle. Next, we take our value for a, which is 2, the first value in our brackets, and write that in descending powers. Then we take our value for b, which is minus 3x, the second value in our brackets, and write that in ascending powers. Then all we have to do is multiply across the rows to find the terms in our expansion. Notice, if one of the terms in the original bracket is negative, the terms in the expansion will oscillate between positive and negative. Here is a slightly more difficult example. We are given one of the coefficients, but the value of c is missing. We need to find c. To complete this question, let's write down what we know. So, first we write down the values from Pascal's triangle for the 6th row. Next, we take our value for a, which is 2, the first value in our brackets, and write that in descending powers. Then we take our value for b, which is minus cx, the second value in our brackets, and write that in ascending powers. The question tells us that the coefficient of x squared is 320, so we only need to work with the row that contains the x squared. With more practice, you will be able to identify the row or the rows to work with without having to write out all the other ones. But for now, writing them out should help you to see what to do more clearly. Okay, so let's multiply out the row that contains the x squared. This gives us 80c squared x squared. And we know that the coefficient is 320. So 80c squared must equal 320. Now it should be easy to find the value of c. So c squared must be 320 divided by 80. This gives us c squared equals 4. So by taking the square root we get the answer c equals plus or minus 2. In this exam question example, we are asked to find the first three terms in ascending powers of x of the binomial expansion of 3 plus kx all to the power of 6, where k is a constant. Give each term in its simplest form. And also, given that the coefficient of x squared is 2.5 times the coefficient of x, find the value of k. The first part of the question requires us to find the first three terms in ascending order. So to begin with, we need to write out the three coefficients of the seventh row of Pascal's triangle. Now let's fill in the rest of the information. Now multiply the rows and simplify. Here we get the answer 729 plus 1458 kx plus 1215 k squared x squared, where k is an unknown constant. To solve part 2, we need to find the value of k. We are told that the coefficient of x squared is 2.5 times the coefficient of x. So, if we multiply the coefficient of x by 2.5, it should be the same value as the coefficient of x squared. Now all we have to do is divide the coefficient of x squared by the coefficient of x to find the value of k. This gives us the answer 3. Thanks for watching, and remember that there are lots more videos just like this one on Mr. Gregory Online.